am Mehdi from Islamic University of Technology. Today I am going to present our paper Performance Analysis of Few-Shot Learning Approaches for Bangla Handwritten and Character Recognition. Problem statement. Despite significant advancements in handwritten character recognition, most existing methods rely on traditional deep learning model and transformer model, which need quite a large amount of data sets. So, few-shot learning is notably has emerged as a promising paradigm to address the scarcity of enabling models to generalize from a minimal number of examples. We are introducing synergy prototype that highlights the potential of the hybrid model to enhance the recognition, accuracy, and efficiency of complex strips. Our comprehensive evaluations include cross-lingual experiments demonstrate the novelty and adaptability of reversal methods across similar yet distinct strips. Here is the basic parameters of the few-shot learning approaches. Few-shot learning is a meta-learning approach where it enables model to generalize over new unseen categorized novel classes. It mimics human learning by leveraging prior knowledge to recognize novel data efficiently. Here are the key terms: superset, which is a few level examples, query set, samples requiring classifications, and novel classes, which are unseen classes that we need to classify, and the episodic training, that is task-based training with subsequent query sets. Here are the state-of-the-art models. This is a prototypical network which uses calculating the distance functions, using the distance functions like Euclidean distance to measure the distance between the classes, and relation network uses relational function to measure the score between the embedding classes. It also uses mean square error to train the model where matching pairs are labeled as 1 and the unmatched pairs are labeled as 0. Simple short models are using nearest neighbor architecture for classifying the examples, and BDC spin is bias diminishing cosine similarity prototypical network, which uses cosine similarity to find out the classes, and the matching network uses the matching function to find the matching score between the classes. So these are the limitations of the prototypical relation and simple short network. These are the main and disadvantages of the state-of-the-art classical models, because they cannot generalize well over unseen examples. So this is our data set that we use for benchmarking our model, Bangla isolated, which contains around 110,000 images across 50 character classes and 10 digit classes. 700 dB 1.2, which provides 30,000 images spanning 50 character classes. Number dB, which is has been created by Bangla AI. It is consists of 5 different datasets dBs, which is around 85,000 images, and the determinant for our cross-lingual evaluation is consists of Indic characters of 92,000 images. So here is our synergy prototype that we have proposed. This is a hybrid model where we use encoder addressed 18 for extracting the local and global features. So our encoder consists of 4 layers. Each one has 3x3 kernel sizes and 64 filters. So our encoder can extract the local features like edges and complex edges features, and also the complex side of the local boundary pixels. Then after extracting the local features, we also used reset 18 for which is a very large deep model that can extract global features from the large amount of area. So here we concatenated both the features using torch concate function. Then we used the prototype creation and distance computation. Here you can see the PC, which is actually a class prototype. So we calculated the PC transporters from averaging our total embedding features, and here you can see the Z cube, which is the embedding feature of the Curie examples. Then we find the distance between Z cube and PC, say P subscript C, using Euclidean distance formulation. So this is the overall architecture. Here you can see that we have used a CNN encoder that can extract the complex local features, and the resonating, which can extract the global features like edges from the large amount of area. Then we concatenate it. Then from the embedding vector area, you can see that we used a distance calculation function like Euclidean distance to measure the classes. Then at the last layer, we uses a softmax layer for classifying. So the embedding feature has been extracted from both the subgroup set and the query set. Then at the last one, we calculated the distance to classify. There is a class formulation that this is the formulation that we have used to examine our synergy coordinate, whether it is good or not, whether it can generalize over new data or not. So monolingual interdataset evaluation was trained on, it was done on the same dataset, that is 7-meter 3.1.2. In here the model was trained on consonants and tested on vowels. And during the monolingual interdataset evaluation, we trained on the Bangla isolated datasets on consonants and tested on the 7-meter 3.1.2 datasets using for vowels. In the cross-lingual transfer, we trained our model with Devanagari, which is an Indic scripts dataset, which is of different languages, not Bangla. And we tested on the 7-meter 3.1.2, which has Bangla letters in it. Then in the split digit testing, we trained our model with the 6 digits 0 to 5 and tested on 3 digits 6 to 9 using the number DB dataset. So these 4 experiments show that we wanted to see whether we can overcome the dataset biases. So this is why we split our experiment for these 4 kind of class formulations. Here are the experimental setup that we use SGD method, that is stochastic gradient descent. And our loss function was cross entropy, and the task per epoch, which is actually episodic training, that is 500 for 500 tasks for training and 100 tasks for practice. Here is our results and findings in the monolingual interdataset evaluation. You can see that synergy coordinate, which is ours, has neck-to-neck performance on prototypical 74.48, but our model has emerged the higher accuracy and F1. In the monolingual interdataset, our model again wins the overall experiment. In the cross-lingual set, where we train our model with different languages dataset, our model did well with 5-shot and 10-shot, where all others model couldn't generalize with more shots. In the performance analysis of split digit testing, here you can see the same result. The matching network did better with 1 shot, but didn't generalize with 5-shot and 10-shot, but our model generalized well with 5-shot and 10-shot. So here is the conclusion for it. Synergy coordinate shows the improved performance in Bangla handwritten and character recognition. It shows the adaptability and robustness. And our future work includes the advanced attention mechanism, whether we can include an attention mechanism in here to enhance robustness of diverse handwriting styles, because different people have different kind of handwriting styles. So we wanted to we include this in our future.